Okay, so the top is the datum. So we are going to have our section. Okay, so we have the section on steel, and then we have the section on aluminum. Okay, and then we specify the N value. Okay, so we specify the N. For steel is 1. For aluminum is 53 over 145. Okay. So next we come with the N multiplied by the width multiplied by depth. Now, when we select, okay, before I go any further, I need to explain something. When we select steel as the reference material, what we just did, okay, I'll start on a new page. When we specify steel as the reference material, right? So what we did is as good as replace the aluminum to what? Steel. Okay, element to steel. And in order to do this, right, without enhancing its strength, I repeat again, in order to do this, without enhancing its strength, so what we just did is the top part, okay, I'm going to sketch down here, okay, the top part, which is the steel, it did not change in thickness. Okay, so this is still what? This is still our steel. Now, in order to change or in order to replace the aluminum with steel, right, without enhancing its property, so what we did when we put in that coefficient over there is basically, okay, we replace the aluminum with steel, but now the thickness has shrunk. Okay, what you see over here, this thickness now becomes 1.5 multiplied by 53 over 145. Okay, that's what we have done. Okay, if we were to, so this is using steel. Now, if we were to replace this with aluminum, so now just for you to visualize, if we were to pick the reference material is aluminum, right? So when that's the case, when the reference material is aluminum, see what I'm doing now. The aluminum did not change in size. Okay, the aluminum itself did not change in size. So now if we're going to replace the top part with aluminum, right? So aluminum being weaker than steel, yes or no? So now the top part will now look like this. Okay, so again, I'm going to draw a box, but I want you to see this, that the height did not what? Change. The only thing that changed is the what? The width. So when you use the reference material as, come on, okay, to steel or to aluminum, right? So now this is aluminum, okay, and this did not change. This is 1.5 inch, But because you replace the top with aluminum, right? You replace the top with aluminum, this distance now, or this thickness now, becomes 145 over 53. Okay, let me write properly. Okay, so this will become 145 over 53. Okay, over 53 multiplied by 1.5. Okay, so that's what we've just done. So the thickness changes, okay? The depth did not change. I repeat again, the thickness changes, note, thickness or width changes. The depth is held constant. Okay. Later on, I'll tell you why. Okay. But let's start finding the centroid first. Okay. So the N1 times by the width is 1.5. Multiplied by the depth is 2. Okay. So this will be equal to 1. So this is equal to 3. And the next one is 53 over 145 times by 1.5 multiplied by the depth of 1. Okay, because the aluminum part is, so 53 over 145 times by 1.5. So it's equal to 159 over 290. Okay. Then next, we do the small y bar from the top. So remember, the thickness did not change. I'll repeat again, the thickness, the depth did not change. Okay, only the thickness changes. Okay, the depth is held what? Constant. Okay, so now the y bar, the datum is at the top. Okay, so 2 divided by 2 is 1. 2 plus by 1 divided by 2, this is equal to 2.5. Then from here, we do our stuff. Hold on. We do our N, W, D, Y bar. Okay, so this is equal to 3, 159 over 290. So 53 over 145 times by 1.5. Okay, which is equal to 159 over 290 times by 2.5. So this is equal to 159 over 116. Right? Then you add all of them together. You do the summation. 3 plus by 159 over 290 is equal to 1029 over by 290. And this one is 3 plus by 159 over 116. And this is 507 over 116. So the y bar now, okay, from the top will be equal to 507 over 116 divided by 1029 over 290. Okay, so 507 over 116 divided by 1029 over 290. So the value is 1.2318 1.2318 inches from the top. Okay. Now, the next thing that we're going to do is we are going to find our second moment of area. So this is equal to IZZ, right? So this will be equal to, again, N width, right? Depth cubed over 12 plus by n width multiplied by depth, okay, big Y bar minus small y bar squared. What I want to draw your attention is this. The n belongs to the what? To the width. The n did not belong to the depth. That's why the depth is held constant. If the depth increases also, what will happen is this term over here will be n depth cube, which is equal to the n cube depth cube, and that is wrong. Okay, that is why, what did I tell you? The depth is held constant, the width is varying. Mathematically, this is the only way to do it. Okay. Now, this way of doing with composite analysis is a what do I call? It's an approximation. Okay, it's easier for us to do hand calculation. In reality, okay, it's not so straightforward. But based on this course, okay, the syllabus state that this is usable, or this we can use this method of calculating the second moment of area. Okay. So from here, we want to find the IZZ. Okay, so we're going to find the IZZ of steel. So the N is 1, the width is 1.5, the depth is 2 cube over 12, plus by 1 times by 1.5, the depth is 2, okay. Y bar is 1.2318 minus by 2 divided by 2, and this thing goes squared. Okay, so from here we have 1 times by 1.5 times by 2 power 3 divided by 12. This is equal to 1. Let me do it again. 1 times by 1.5 times by 2 power 3 divided by 12. This is 1 plus 1.2318 divided minus by 1 squared times by 2 times by 1.5 is equal to 0.16 1612. Okay, so this over here is equal to 1.1612 inches to power 4. So the next thing we're going to do is we're going to look for IZZ for the aluminum. So now we have to include the 53 over 145 times by the thickness of 1.5. The depth is 1 cube over 12. Okay, then we plus again 53 over 145 times by the width of 1.5 times by the depth of 1, and then the Y bar is 1.2318 minus by what? Minus by 2.5, right? And the whole thing squared, right? So from here, this will be equal to 53 over 145 times by 1.5 times by 1 divided by 12. So this will be equal to 53 over 1160. Let me do it again. Yeah, plus by 1.2318 minus 2.5 squared the whole thing times by 1 times by 3 over 145 times by 1.5. So this will be equal to 881.8092 times 10 to the power minus 3. Let me do it again. 1.2318 squared. Correct. So this will be equal to 53 over 160 plus by 881.8092 power minus 3. So it's equal to 1. Hey, 1. I'm not getting the right number somewhere. Hold on. 1.2318 minus 2.5 squared times by 1 times by 53 over 145 times by 1.5. 81 point, yeah, plus by 53 over 1160.